2300, 2250 Ma. Key events and processes. Initial post-Archean rifting and crustal extension along the southern superior craton margin, forming fault-bounded basins as part of a passive margin development. Onset of bimodal, mafic felsic, volcanism and sedimentation in response to lithospheric thinning. Thermal anatexis, partial melting, of Archean gneisses, linked to mantle upwelling. Early stages of the Great Oxidation Event influencing shallow water chemistry, leading to banded iron formation, BF, precursors. Rock formations and descriptions. Campo Creek gneiss, partial melting of Archean basement. Early clastic wedges and volcaniclastics, correlated to lower Huronian equivalents, e.g., quartz pebble conglomerates. Layered gabbroanorthosite intrusions, UPB ages 2480, 2491 Ma, but with Rhyacian overprint. Region modern U.S. Northern Michigan, Dickinson County, East Central Minnesota. Significance. Marks the shift from stable Archean craton to dynamic Proterozoic margin. Rifting sets stage for basin development. 2.3 to 2.2 billion years ago. Onset of the Rhyacian after the Siderian. O marks continuation of the Great Oxidation Event, GOE, when oxygen levels in Earth's atmosphere rose significantly due to photosynthetic cyanobacteria. O in what is now the U.S., banded iron formations, BIFs, continued to accumulate, especially in regions that would become Minnesota and Michigan. These massive iron deposits formed as dissolved iron in oceans reacted with free oxygen. O Laurentia, the proto-North American craton, was assembling and growing via accretion of smaller landmasses. Early Rhyacian, 2.3 to 2.2 GA. Global context. The atmosphere is becoming oxygenated, leading to the first rusting of the Earth and the formation of banded iron formations, BFs. The first global glaciation, the Huronian, may have begun late in this phase. Events in Laurentia. The future North American continent existed as separate cratonic blocks, e.g., the Superior Craton, the Hearn Craton, the Wyoming Craton, surrounded by vast oceans. Subduction initiation. Around the margins of these cratons, oceanic plates began to subduct beneath the continental nuclei. This process built volcanic island arcs, similar to the modern-day Japanese archipelago or the Andes, and caused the accretion of oceanic plateaus and smaller continental fragments onto the craton's edges. Evidence today. Rocks from this time are rare in the U.S. due to extreme metamorphism and later overprinting. The deepest gneisses and granites in the Black Hills of South Dakota and the Beartooth Mountains of Wyoming/Montana contain components this old, indicating they were part of the growing edge of the Wyoming Craton. 2250, 2200 Ma. Key events and processes. Continued rifting with deposition of fluvial lacustrine sediments and glaciogenic deposits. Second and third Huronian glaciations, part of global snowball Earth episodes. Mafic dike swarm emplacement, e.g., early phases of Molson swarm precursors. Intrusion of granitic bodies during extensional tectonics. Sedimentation in platform to basinal settings, including turbidites and chemical precipitates. Rock formations and descriptions. Mataninda formation equivalents. Uranium-bearing quartz pebble conglomerates. Turbiditic graywax, siltstones. McKim and Hoff lake groups. Conglomerates, sandstones, peelites. RB senior age 2240 Ma for glaciogenic units. Murray and Creighton granites. Felsic intrusions. UPB ages 2333, 2388 Ma. Region modern U.S. Northern Wisconsin, northern Michigan. Inferred in Minnesota from basin correlations. Significance. Glaciations reflect atmospheric oxygenation. Conglomerates host early uranium mineralization. Granites stabilize crust. 2.2 billion years ago. Glaciation evidence. North America preserves signs of Palaeoproterozoic glaciations during the GOE. In what is now Wyoming and Michigan, deposits hint at large-scale ice ages triggered by the climatic shifts of rising oxygen reducing greenhouse gases, like methane. Proto-continental crust of the Wyoming province and Superior province began suturing together. 2200–2150 Ma. Key events and processes. Peak of rift basin sedimentation under fluvial to shallow marine conditions, with angular unconformities indicating minor deformation. Mafic volcanism and dike intrusions, e.g., Molson Dike swarm at 2170 Ma. Deposition of glaciogenic diamictites and overlying post-glacial sequences. Early compressional tectonics with folding of lower sequences. Rock formations and descriptions. Mill-lax group, quartz aaronites, siltstones, shales, sulfide-rich black shales, carbonate, and silicate facies iron formations. SMND age 2197 Ma. Upper Huronian equivalents. Cobalt group, Gauganda formation glaciomarine diamictites, Lorraine formation sandstones. Chocolate group, siliciclastic sediments in basinal/platform settings. Region modern U.S. East central Minnesota, northern Wisconsin, southern Michigan, upper peninsula. Significance. Volcanics indicate mantle plume activity. Iron formations signal increasing oxygen levels. Unconformities show tectonic pulses. Mid-Rhyacian, 2.2 to 2.1 Ga, the peak of orogeny. Global context. The Great Oxidation Event is underway, causing a mass extinction of anaerobic life and fundamentally changing surface weathering processes. Events in Laurentia. The Trans-Hudson orogeny. This was the most significant tectonic event of the period for North America. The Superior Craton, now centered on the Great Lakes, and the Hearn Craton, to the northwest, began to collide with each other. This was a Himalayan-scale collision that closed an entire ocean basin, the Manicouagan Ocean, between them. The Cheyenne Belt orogeny. Simultaneously, to the south of the Superior Hearn collision, the Wyoming Craton was moving towards the growing protocontinent. The ocean between them, the Montana Ocean, began to close, and the Wyoming Craton collided with the southern margin of the combined Superior Hearn landmass. This collision created the Cheyenne Belt, a massive suture zone that is now a fundamental geological boundary. Evidence today. The Trans-Hudson orogeny is exposed today in Canada, but its effects extend into the northern U.S. It forms the basement rock beneath the Great Plains in states like North Dakota, South Dakota, and Montana. The Cheyenne Belt is a major geological feature exposed in the Medicine Bow Mountains of Wyoming and the Black Hills of South Dakota. It represents the deeply eroded root of the massive mountain chain created by this collision. Rocks here are intensely deformed and metamorphosed, telling a story of immense pressure and heat. 2.15 to 2.1 billion years ago. Tectonic collisions in Laurentia. The Wyoming province, underlying parts of Wyoming, Montana, South Dakota, began docking with the Superior province, centered on present-day Great Lakes region. Metamorphic belts and greenstone belts formed in what are now northern Minnesota and Michigan. Sedimentary basins in what is now Arizona and New Mexico record the stabilization of early continental crust. Oxygen levels fluctuated. Shallow marine ecosystems in Proto-U.S. basins saw some of the first localized oxygen-rich environments. 2150–2100 Ma. Key events and processes. Transition to foreland basin development as rifting wanes and convergence begins. Bimodal volcanism, mafic lavas, felsic tuffs, and clastic sedimentation in deepening basins. Emplacement of mafic sills and dikes, minor granitic plutonism. Low-grade metamorphism and deformation of earlier sediments. Rock formations and descriptions. Anemiki basin sequences, clastics, mafic volcanics, subordinate chemical sediments. Unconformable on 2120 Ma dikes. Palms and Pachygamma formations, tidal shelf deposits, precursors to superior type BFs. Early Barriga group, stratified rocks with iron formations. Region modern U.S. Northern Minnesota, northern Wisconsin, northern Michigan. Significance. Basin marks shift to passive margin. Dikes, 2120 Ma RB Senior. Linked to regional magmatism. Sets up later Pinocchian deformation. 2.1 to 2.05 billion years ago. End of the Rhyacian period. Laurentia continued to consolidate into a more coherent craton, setting the stage for the later supercontinent Columbia, Nuna, around 1.8 GA. Rocks of this age in the Black Hills, South Dakota, and Grand Canyon region preserve early crustal growth episodes. Banded iron deposition slowed by the end of the Rhyacian as free oxygen began to build up in the oceans and atmosphere, reducing available dissolved iron. Late Rhyacian, 2.1 to 2.05 GA. Global context. Oxygen levels continue to fluctuate. The assembly of these cratons is part of the larger formation of Earth's first hypothesized supercontinent, Kennerland, or, more likely, its incorporation into the later supercontinent Columbia, Nuna. Events in Laurentia. The major collisional events, Trans-Hudson and Cheyenne Belt, began to wind down, but tectonic activity continued along the margins. Wapme orogeny. While primarily in northwestern Canada, this orogenic event involved the accretion of terrains onto the western margin of the growing Laurentian continent, shaping the continent's far western basement. Post-collisional relaxation. As the massive mountain belts built in the Mid-Rhyacian began to collapse under their own weight, the crust stretched and thinned. This allowed for the intrusion of vast bodies of magma that cooled underground to form granitic plutons. Evidence today. The 2.05 GA Harney Peak granite in the Black Hills of South Dakota is a classic example of this post-orogenic magmatism. It is one of the most well-studied granite systems in the world and represents the final cooling phase of this immense tectonic event. Deep crustal rocks exposed in the Wind River Range of Wyoming and the Adirondack Mountains of New York, which were connected at this time, also bear the imprint of late Rhyacian metamorphism and deformation. 2100-2050 Ma. Key events and processes. Onset of compressional tectonics, Proto-Pinocean phase, with nappe formation and thrusting. Continued sedimentation in wedge-shaped foreland basins, thickening southward. Granitic intrusions and regional metamorphism, green schist to amphibolite facies. Final glaciogenic events, possible fourth Palaeoproterozoic glaciation. Rock formations and descriptions. Rainy Creek Formation, mass flow deposits, post-Menominee age. Menominee group, siliciclastics with iron formations. Lower Proterozoic stratified rocks, e.g., mass flow conglomerates, volcaniclastics. Region modern U.S. East Central Minnesota, Northern Wisconsin, Northern Michigan, Gogebic Range. Significance. Tectonics herald full Pinocean orogeny. Iron formations become economically significant. Period ends with craton stabilization.